photoelectric effect. So today we are going to start by looking at the graph, the normal graph of a straight line. That is a graph of y against x. So, and we are going to use the equation of y is equals mx plus c to see or to interpret the graph. So we are going to start with the we have the graph here, a straight line. So y represents the y-axis. Y in the equation of y is equals mx plus c represents the y-axis. Then we have x, which represents the x-axis. Then we have c, which represents the value at which the graph cuts the y-axis, also known as the y-intercept. So c simply represents this value. For example, our value here is negative. That means the value you get after reading the point whereby the graph cuts the y-axis. That is why you get the value. In our case here, we call it the y-intercept. Then we have m. So if the full equation is in the form of y is equals mx plus c, then m, the remaining m now becomes the slope. And in this case, the slope will be change in y divided by change in x. So that is our slope, which will be represented by letter m. So with this correlation, I want us now to go to look at other scenarios. So we're going to look at the three equations of photoelectric equation. So, and in the first case, we are going to look at the graph, a graph of kinetic energy against the frequency. So we have the graph of kinetic energy against the frequency. So if you look at this graph, we normally say that the kinetic energy is the energy of the particles or the radiations, the particles or the electrons which have been emitted by the incident radiation on the metal surface. Remember, when we are talking about photoelectric effect, we are simply saying that when a radiation of a particular frequency strikes a metal surface, it is able, when a radiation of a particular frequency strikes a metal surface, it is able to dislodge electrons from the metal surface. It is able to dislodge electrons from the metal surface through the photoelectric effect. So that means the energy of the incident radiation, that is the radiation that is striking the metal surface, will be used first to dislodge the electrons, and that is the one we call work function. And then the remaining energy will be used to drive the electrons or to move away the electrons. That means from the law of conservation of energy, the energy of the incident radiation that will be dislodging the electrons will be used first to dislodge the electrons and then to move the electrons. But it's important to note that the energy of the incident radiation can be found from HF, that is Planck's constant times the frequency. So, and that means E can be replaced by HF, that is Planck's constant times frequency, because our interest is to rearrange this equation in the form of y equals mx plus c. So that is our interest, whereby we saw from the previous case that y represents the y-intercept. So that means in our case, we need to have kinetic energy being the the subject of the formula. So that means by taking work function on the other side, we'll have now the equation kinetic energy is equals HF minus work function, since we took the work function on this other side. So, and that means kinetic energy is the y-axis. Then we have F, which is the x-axis, and then we have negative W naught. That means in our case now, negative W naught will be representing the kinetic energy intercept. In other words, if we are relating with the mathematics, it means now C will be representing the value we get from y-axis, and that simply implies that in this case, negative W naught will be representing the kinetic energy intercept. Then if we go to the second part, we have M, which is our H. That means the slope of this graph represents the Planck's constant, since it is M. So that means if you are told to find the Planck's constant from this graph, you are simply told to find the value of the slope. So that is how we interpret that first graph. You can send your feedback, or maybe you can send your questions on the comment section. I want us now to go to the second graph. That is the graph of stopping potential versus the frequency, or the stopping potential against the frequency. So again, we know the energy of the incident radiation will be used as work function, then the remaining energy will be converted to kinetic energy. That means the energy will be used first to dislodge the electrons, and then after dislodging them, they will be moved. So that means the kinetic energy, the incident energy can be written as HF, that is the energy of the radiation. That means we replace E with HF. Then kinetic energy can be written as EVS, meaning the charge of an electron times the stopping potential, or the stopping voltage. So E is the charge of the electron, Vs is the stopping potential, or the voltage. So that means if we replace the value of EVS and HF in the equation, the general instance equation, remember this one is the general instance equation, so we'll have HF equals W naught plus EVS. So relating from our mathematical equation, we need to have Y being the subject of the formula. So that means in this case, we are going to make Vs the subject of the formula in our case here. So we can take W naught this other side, then you divide everywhere by E. So that means the new equation now occupies this shape, that is after taking W naught this side and then dividing everywhere by E to remain with Vs. And if you look at this equation critically, you realize now Vs is the y-axis, and then we have F, which is now the x-axis. And that simply means negative W naught all over E represents the Vx intercept. That represents the Vs intercept. And then we also have, after removing x is a frequency, so m remains as h over e. So, and that means the slope of this graph, change in Vs over change in f, represents Planck's constant all over charge of an electron. Remember, charge of an electron is a constant. So that means if you are told to find the slope of this graph, you'll simply find, if you are told to find the Planck's constant from this graph, you are simply told to find the slope, then you multiply by the charge of an electron, which is 1.6 times 10 raised to the power negative 19 coulombs. So you can be able to get the Planck's constant. So lastly, we go to the last graph, the third graph of photoelectric effect. So the graph is a graph of stopping potential against reciprocal of wavelength. So in this graph, all the graphs have a similar shape, and then we look at the general equation, the general instance equation. We have energy equals W naught plus kinetic energy. So if you look at the equation, you realize that first of all we need to replace, because we need Vs in the equation, we also need wavelength in the equation. So that means energy can be written, kinetic energy can be written as HF. But remember, frequency equals speed over lambda from wave equation. So that means HF can also be hc over lambda, because we know frequency is c over lambda from the wave equation, where c is the speed of light or the speed of the wave over wavelength. Then we also have kinetic energy, which can occupy EVS. Remember, kinetic energy has three formulae. We can have half MEV squared. We can also have EVS, or can just be kinetic energy as it is. Remember, this other energy also E can also occupy two forms. It can be in the form of HF, can also be in the form of HC all over wavelength. So that means if we make V as the subject, if we make V as the subject here, we'll take W naught this other side, then we divide everywhere by E. So the new equation is this one. That's the new form of this equation, which is in the form of y equals mx plus c. So if you look at this equation, you realize that Vs is the one we have here. 1 over wavelength, we have it here. That means this one is the same as hc all over E times 1 over wavelength. Hc all over E times 1 over wavelength. And that means the slope. That means the slope represent hc over E. Remember, C and E are constants. C and E are constants because these are the C and E are the speed of light, and also we have the speed of light, and then we also have the change of an electron, which are all constants. So we have the speed of light and the change of an electron, which are all constants. So that means in this case, that means hc over E, you just require to find h, because you have C and you also have the value of E, and we have the constants here. So then lastly, the value here, the intercept, the Vs intercept represent negative W naught all over E, whereby we know the value of E. So that means if you want the wavelength from this graph, you simply need to read this value, then you multiply by the change of an electron, then you'll be able to get the value of work function W naught. That means you can get W naught from reading this value. Then you say negative W naught all over E, which is 1.6 times 10 raised to power negative 19 equals the value you get here. Then you multiply by E both signs. That means this negative here will remove this negative here, because the value here is negative. So that means you should not be worried about that negative. So that marks the end of our general equation. So it's important to note that when you are looking at the photoelectric equations, the three equations of photoelectric effect, which normally carry a lot of marks in physics paper 2, first you need to interpret and also to be able to decode the equations, the instance equation and the graphs in terms of the equations of a straight line, and then you can be able to use them now to solve the required equations. So that marks the end of our lesson today. Don't forget to subscribe and also to like our channel. You may also share with your friends and also your fellow students, so that at least they can also partake of this and learn some few tips. So I want to wish you a very good moment as you stay, and also remember to follow our channel. Thank you and have a good day.